So what I have done, I have taken some examination questions. The question is to the top, and I have put the theorem there. Now, in these types of questions, which is circle theorems, it is worth 6 marks of the CSEC past paper. You will get 1 mark for stating the size or the measure of the angle, and you will get 1 mark for the reason. Now, the first question, and I do hope that you all can see it properly. We have points Q and S lie on the center of the circle. So if a line starts from the center and it touches the circumference, we have a special name for that. It is called the radius. Do you all agree?
Yes.
Yes. Right. Now, a tangent touches the circle at one point. So this line here is what we call a tangent. The angle at R is 40 degrees. The angle at O is 80 degrees. They ask us to prove that this triangle in green is an isosceles triangle. So that is what we want to prove here this afternoon. All right. What are some of the features of an isosceles triangle?
We have two both parallel sides.
Yeah, there's 2 sides.
We have 2 equal sides and 2 equal angles, right?
Yes.
Right.
Yes.
Now, look at this. I have 2 theorems. The theorem 1 says that if I have a radius and it meets a tangent, the angle formed is a 90 degrees. Do you all see that? Right? Now, the second theorem says an isosceles triangle is formed where 2 sides of a triangle are the radii. So radius singular, radii plural. So here, this is a radius and this is a radius. So it means this angle is equal to this angle. Right? Yes. So this is an isosceles triangle. So this angle is equal to this angle. So let me just draw that triangle for you. What is the sum of angles in a triangle? How much do they add up to?
180.
180. 180. So if we know that the sum of angles is 180, work out the angle at S and work out the angle at Q for me. Give the others a few minutes, right?
Yeah, let's finish.
Remember that this angle here must be the same. So you will take your calculator, you will subtract 80 from 100, 180 minus 80, sorry, you will subtract 80 from 180 and you will get 100. Did you all get 100?
Yes.
Yes, yes.
And 100 divided by 2 is 50. Do you all agree?
Yes.
Right. So it means that, let me see, this angle here is 50 and this angle here is also 50, right? No, we're not finished yet. They said that the tangent meets the radius at 90 degrees. So look at this, right? Look at this. This is the tangent and that is the radius. This whole angle is 90 degrees. What is this angle here? if this part is 50, what is the other part there?
90 minus 50.
40.
You'll get 40 degrees. Yeah.
90.
Minus 50 degrees.
That's
Yes.
not what it is. Here is 90. What's going on with my pencil here? That's not it. Right. So this here is 90 minus 50, which is 40 degrees. Do you all agree?
Yeah,
Yeah,
miss.
man. Yeah, man.
So if this angle is 40 degrees and this angle is also 40, what type of triangle is this?
Isosceles, miss.
Isosceles. Yeah.
An isosceles. So they ask us to prove that the triangle is an isosceles, right? So it is an isosceles because, and the reason is the radius meets a tangent at 90 degrees. Now, take down whatever you need on the screen. I suggest that you don't write everything that I have. The note will be sent for you. So just look over the solution and let us continue.
Excuse me, which paper is this?
So this is some exam questions, right? Taken from the CXC website. So it's not one of the past papers. The past papers, we will do that later on.
Okay.
What I have realized is that if I do the past papers with you without you seeing the connection, you are unable to make that link with the theorem and the question. So I pulled together some questions, right? And all of these are past paper questions, but this was done like probably in the year 2000, 2004, 2005, around those years. So these are the older past papers. All right, let's go to the other one. Now look at this. A, B, and C are the points on the circumference of the circle with center O. B, D, and CD are tangents. So this is a tangent here, right? So this is a tangent, and this here is also a tangent. Are you all seeing that?
Yes, miss.
Right. Now, the theorem says a radius meets the tangent at a right angle. So this from the center O to the circumference, this angle here is a right angle. Do you all see that?
Yes.
Yes.
So if this is the right angle, what is the measure of P? So,
Miss, it could be
all right, hold on. How many degrees do we have in a
260.
quadrilateral? 360. So if this is a right angle and this here is a right angle, this angle is 40 degrees. How much would this angle here be?
140.
Could anybody else confirm that this angle is 140?
yeah, miss, correct. 180 minus 40.
So here is 140. Do you all understand how I got that?
Yes, miss.
Right. So that was this theorem that I have in yellow here. So the reason why P is 140, and you have to state the reason, is that a radius meets the tangent at a
Right angle.
right angle. So that is the reason. All right. Now, I have another theorem here. What does this one say?
The angle at the center is twice the angle at the circumference.
The angle at the center is twice the angle at the circumference. Do you all see that?
Yes.
No. So if I have this angle here as 50 degrees, how much would this angle here be? If it is
100.
twice, 100.
degrees.
So what about if I have this angle to be 100? What would this angle here be? How would you get that?
100 divided by 2.
100 divided by 2, which is 50.
50.
So if this angle here in yellow is 140, what is this angle here?
140 divided by 2, which is 70 degrees, miss.
Yes.
140 divided by 2, which is 70 degrees.
Yeah, miss.
And what is the reason?
The angle at the center is twice the angle at the circumference.
All right, so let's write that. The angle at the center is twice the angle at the circumference. So you could take down the writing, but you can leave the diagram. I will send this to you at the end of the class. So on the worksheet, there are questions and there are the theorems. So you need to know the theorem in order to answer the question. All right? All right, let's go. Look at this one. We want to explain why ABC is 100 degrees. Now, how do I call this line here that touches the circle at one point? What is the name of this line?
Tangent.
A tangent.
Yep.
All right. So this is called a tangent. How do we call this line that starts from the center and it touches the circumference?
Radius.
A radius.
Radius.
Right? What is the rule? The radius meets the tangent at what angle?
90 degrees.
Right angle. Well,
90 degrees. Right. Now watch this. Can you find? So instead of doing that, we want to find ABC. Right. What shape is this? It has 4 sides. What do we call this shape with 4 sides? It starts with Q.
Quadrilateral.
A quadrilateral. What is the sum of angles in a quadrilateral? What is the sum of angles in a square?
360 degrees.
So in a quadrilateral, the sum of angles is equal to 360. Do you all agree?
Yes.
When 2 tangents meet at one point, the lines are equal, right? So it means that this angle is 40. work out for me this angle here at B. So work out this angle for me here at B. So here we have 40 plus 40. Here we have 90 degrees. Here we have 90 degrees. So work out the angle at B. If the sum of the angles is 360. Anybody? What's the answer?
100, miss.
100.
100.
Do you all agree it is 100?
Yes,
Yes,
miss.
Yes.
And the reason is a radius meets the tangent at 90 degrees. So you will get 1 mark for the answer and 1 mark for the reason. Let's go again. Now look at this diagram. So this one is similar to what you have been seeing in the past papers, right? The tangent DB is extended to form T. AO is added on the diagram and the angle at B is 62. We want to work out the value of X. Now, the radius meets the tangent at what angle?
90 degrees.
90 degrees. Do you all agree that the radius meets the tangent at 90 degrees?
Yes, miss.
Yes, miss.
If this angle here is 90 degrees and this part here is 62, what would this part here be in purple?
It will be 90 degrees to 62 equals to.
Did you all hear what he said?
Yes, miss.
So here's what it looks like. Eh? Let me see if I could erase it here. Let me go again, in case you are not seeing it. This is my tangent. This is my radius. So it means that this is a 90 degree and this here is also a 90 degree. Are you all seeing that?
Yes.
Right?
Yeah, miss.
But this angle here is already 62. So this angle here would be 90 minus 62, which is 28 degrees. Do you all agree with that?
Yes, miss.
Yes.
All right. All right. So I erasing this. Right? I'll draw it back just so. So if this is the center and this is my circumference, this line is called, what is this line called? From the center to the circumference?
Radius.
A radius.
Radius.
This is a radius and this is a radius. So what type of triangle is formed with two radii?
Isosceles.
Isosceles. Isosceles. So if this angle here is 28, what would this angle here be?
22, miss.
28.
28. Do you all agree?
Yes, miss.
Yeah,
Yes,
miss.
miss.
Right. We get in somewhere. What is the total sum of angles in a triangle?
180.
180. So if you know two angles, can you find the third angle?
Yes, miss.
Yeah, miss.
All right, go ahead and find it. And if you find it already, give the others a few minutes, right?
Yes.
All right. This angle is equal to this angle here. What is the value of x? Anybody?
124, miss.
124. Can someone confirm his answer?
Yeah, miss, you correct.
Yes, miss.
Yeah, miss.
But why is that angle 124? What type of triangle it is?
Isosceles.
Yeah, miss.
So the reason is OAB is an isosceles triangle. Right? Yes?
Yeah, miss.
Yeah, miss.
Right. If I extend this tangent here, what is the angle formed here and the angle formed here? The radius meets the tangent at 90 degrees. Do you all agree?
Yes, miss.
Yes, miss.
Right? So go ahead and find this angle here for me. If a quadrilateral has 360 degrees, find that angle for me in purple.
Finish, miss.
Give the others a few minutes. I know, give them a few minutes. Let me redraw the quadrilateral. This is the quadrilateral here. The sum of angles in a quadrilateral is 360. So here would be 360 minus 90 plus 90 minus 40 plus 40. What answer did you all get?
220.
What was that?
96, miss. That's the answer.
No,
No, 140, miss. You got 140.
140.
Oh, yeah.
Yeah.
140. So the angles in a circle or the angles at a point add up to 360. So what is the measure of angle at O if here is 124? Work it out. (360) minus 124 minus 140.
96 degrees, miss.
Yeah, miss.
96. Did anybody else get 96?
Yeah, miss. I get that.
Yes, miss.
Right. So if this is 96, this angle must be equal to this angle because this is a radius too, not so?
Yeah, miss.
So work out the measure of angle Y. 180 minus 96 divided by 2.
$42 degrees, miss.
Yeah, miss.
42 degrees. Could somebody confirm that it is 42 degrees?
Yeah, miss.
Yes,
Yeah,
miss.
miss.
So OAC is an isosceles triangle. All right, we're going again, right? Because I'm sending this for you all. All right, let's look at this one. And let's look at the theorems that are associated with it. Now, teaching us some mathematics here. We have a circle. A chord starts from one point on the circumference and it touches the other point on the circumference. That line has a special name. It is called a chord. Right. Now, a chord separates a circle into two parts. We have this part here in orange, is the smaller part. Are you all seeing that?
Yeah,
Yes,
miss.
miss.
Right? So we have a special name for that because it is the smaller part. We call here the minor segment. And the larger part here, this piece, because it is bigger, it is called the major segment. Right, now, the angles in the same segment of a circle are equal. So this here, these two angles, we have an imaginary chord here, or it could come from the arc, right? It could be from the minor arc. If this was my chord that I now draw on my diagram, these two angles are on the major segment. Do you all see that?
Yes.
So angles on the same segment are equal. The next theorem says the angle in a semicircle. But the word semicircle, how much is that? Half, 3/4, a quarter of a circle.
Half of a circle, miss.
Half of a circle.
Yes.
So if a semicircle is half of a circle, one side must be the diameter. I don't know if you heard that. A semicircle is half of a circle. So if a triangle is found in a semicircle, it means one length of the side is the diameter. So once that happens, a right angle is formed. Are you all seeing that?
Yes, miss.
Now, I want you to look at this. This is my chord without saying anything, right? Look at it and tell me, give the others a few minutes, please. Tell me what is the value of X and Y. So think about it. Without saying the answer out loud, think about it. What is the measure of angle X and Y? The answer is there on the screen. Are the angles on the same segment? Are the angles formed on the same segment?
Yes.
Yeah, miss.
Yes or no?
Yes, yes, miss.
Yes, miss.
Is it on the minor segment or the major segment?
The
The bigger part or the smaller part?
The bigger part.
bigger part.
Major.
So it's the major segment. You all see that?
Yes, miss.
Yes.
All right. If I were to tell you that X is 65 degrees, would you all agree?
Yes, miss.
What would the reason be?
Angle on the same segment are equal.
Yeah, miss.
Angles on the same segment are equal. Do you all see that?
Yeah, miss.
Right.
Yeah, ma'am.
Now, we are finished yet. We find X and we find Y. What does this line says? Did it identify the diameter of a circle? Did it tell you which length is the diameter?
Yes, miss.
Yes, miss.
So if AC is the diameter, what type of triangle is found in that semicircle?
In right angle triangle.
A right angle
Right
triangle.
angle.
So it means that the angle at P is 90 degrees. So without you saying the answer out loud, work out the value for me of Y.
Yeah, miss.
Give the others a few minutes, right? What is the measure of angle Y?
25 degrees.
25. And the reason is AC is the diameter, or you can say that ABC is a right angle triangle. Do you all see that? Did you all get you angle Y to be 25?
Yes, miss.
Yes, miss.
Yes, miss.
Very good. Now, I need you all to see the relationship with the question and the theorem. That is why we're going it through slowly and we're taking our time. Let's go. We're going again. Look at our diagram. P, Q, and R and S lie on a circle. PQ is equal to QR, and the angle at PQR is 116. Explain why QSR is 32. Now, you see this line here? This line indicates that the length of PQ is equal to QR, and it was stated here in the question. If a triangle has two equal sides, what is the name of that triangle?
An isosceles triangle.
An isosceles triangle. I feel it in here. Repeat that, Malik.
An isosceles triangle.
Do you all agree with what he said?
Yeah, Mr. Correct.
What are the properties of an isosceles triangle? They have two sides equal, and what else? If these two sides are equal, what do you know about the angles?
The angles are also equal.
The angles are equal. So the angle at P is equal to the angle at Q. So find for me the measure of angle P and R. If the sum of angles is 180, work out that for me. If all three angles give me 180, work out the measure of angle P and R. So 180 minus 116 is 64. 64 divided by 2 is 32. Did you all get 32?
Yeah, Miss.
Yeah, miss.
All right. Is there anybody in the class who didn't get 32? All right. Now, this is a chord. Yes?
Yeah, Miss.
This is the minor segment. So it means that the angle at S and the angle at P are on the same segment. So the angle at S would be how many degrees? How many degrees would the angle be if they are on the same segment? Angles on the same segment are
Well,
equal. So if
So it will
this
be 32.
angle here is 32 degrees,
It will
how
be 32,
much would
Miss.
this
yeah,
angle
miss.
be?
32.
32.
Do you all agree? Or you're still not sure?
Yeah, Miss, I agree.
All right, for those of you all who don't understand, this is a chord. The chord separates the circle into two parts. So this angle here and this angle here are equal. The angles here, if here is A, here would also be B. A. So the angles on the same segment are equal. So if this angle is 32 degrees, here would also be 32 degrees. Do you all see that?
Yeah, miss.
Yeah.
So the reason is angles on the same segment are equal. Does anyone have any question? Do you all understand why the angle at S is 32?
Yes, miss.
Yes, miss.
Can I move on, or do you all want me to go it over? All right, let's go. All right, look at this one. Let's go through the theorem first. The angle at the center is twice the angle at the circumference. So if I have a circle, right, and I have a center angle, this angle is twice the angle at the circumference. I could draw it like this as well, right? I can draw it like this. These angles are the angles at the circumference. And the angle here at the center is 2 times. So if this angle is 75, here would be 150. If this angle is 200, here would be 100 degrees. Do you all see that?
Yeah.
Yes, miss.
Yeah.
All right, so let's go. Having said that, work out for me or figure out what is the measure of angle X. And the theorem is the angle at the center is twice the angle at the circumference. So look at it and look at the theorem and see if you can figure out what is the measure of angle X. Does anybody have an answer?
100 degrees, miss.
100 degrees.
Why is 100?
Because both sides of the angle is equal.
What? I tell
No,
you
miss,
anything
my
about
bad.
both sides of the
No, it's
angle
just
is equal?
miss, I kind of forget the theorem. That's all.
What is the theorem? Look at it on the screen.
The angle at the center is twice the angle at the circumference. Sorry,
All
what
right.
I missed.
All right, the angle at the center is twice the angle at the circumference. Do you all see that?
Yeah, miss.
All right. Is anybody confused as to why X is 100? All right, let's go. Watch this one. Remember some time ago in Form 3 or Form 2, I don't know what form it was, they told you about shapes, and depending on the number of sides a shape has or a figure, that is the name that it will get, right? For example, a triangle has 3 sides. A quadrilateral has 4 sides. A pentagon has 5 sides. A hexagon has 6 sides. Do you all remember that?
Yeah, miss.
Yeah, miss.
Well, if you didn't remember it, you're hearing it now. Now, this is 1 side, 2 sides, 3 sides, 4 sides. So if the figure has 4 sides, it is called a quadrilateral. An example of a quadrilateral is a rectangle. This has 1, 2, 3, 4. Do you all agree?
Yeah, miss.
An
Yeah, miss.
example of a square, of a four-sided figure is a square. We also have a kite, we have a rhombus, etc. All right, so let's continue. Now, if I have a circle and I have a four-sided figure, which with each corner touching the circumference, there is a special name for that shape. Let me repeat that. The rule is there must be a circle, there must be a four-sided figure in the circle with each corner touching the circumference. This is called a cyclic quadrilateral. And the properties of the cyclic quadrilateral, if this angle is 80 degrees, this angle would be 100 because the sum of the opposite sides are supplementary. The word supplementary it means that it adds up to 180. You all remember that from primary school, supplementary, complementary. I'm sure you all remember that.
Yeah, miss.
Right. So if this angle here is 40 degrees, what would this angle be? What would this opposite angle be?
140.
140. And
140.
when I take my calculator or whatever, and I add 80, and I add 40, that is 120. 120 plus 100 is 220, and 220 plus 140 will give me 3.
Is me or messed up now?
I say the same thing.
I guess you're right.
I ain't since yeah, so I jump.
All right. So apparently I was talking to myself just a while ago. All right. So which angle is opposite to y? Are you all seeing the
50.
diagram?
Yes, miss, we are.
Which
Yes, miss.
angle is opposite to y?
50.
50. What do you know about the sum of 50 and y? How much do they add up to?
180 degrees.
All right. Take a few minutes. Work out the value of y.
I want to see. Yeah.
Do you all agree with him?
Yeah, miss.
Yeah, miss.
Yeah, miss.
Because y plus 50 is equal to 180. So y is equal to 180 minus 50, which is 130. And the reason is opposite angles in a cyclic quadrilateral are supplementary. If you can't remember supplementary, you just write that they add up to 180. Do you all understand that?
Yes.
Yes, miss.
All right. We're going again. All right. Without me telling you anything, see if you could figure out that question. See if you could identify the cyclic quadrilateral and see if you could identify the angles on the same segment. You all ready?
Yeah.
All right. Remember this shape here says angles on the same segment are equal. So what is the measure of x?
40.
40 degrees.
40.
Right? X is 40 degrees. And the reason is angles on the same segment are equal. All right, that was one part. How do we call a four-sided figure that is found inside of a circle with all the corners touching the circumference?
A cyclic quadrilateral.
A cyclic quadrilateral. And what do you know about the cyclic quadrilateral? The opposite angles add up to how much degrees?
180 degrees.
180.
180. So if you know that, can you find y?
Yeah, miss.
So y is equal to 180 minus 40 degrees, which is 140. The reason is opposite angles in a cyclic quadrilateral add up to 180, or the sum of the angles in a cyclic quadrilateral. Right. Are we okay so far? Yes?
Yes.
Yes, miss.
All right. Now, this is the last theorem here. What does this one say? Let's see. All right. It's a little bit wordy, but this is also called the alternate segment theorem. All right. The angle between the tangent and the chord. Well, let us first identify the tangent and the chord. All right. So we go in. AB touches the circle at one point. So therefore, AB is called the tangent. Do you all agree?
Yeah, miss.
Yes, miss.
No. CE is called the chord. because it touches one point, right? It touches one point of the circumference and the other. So this is called the chord. So we identify that, the angle in between. So this is the angle in between the chord and the tangent. You all seeing that? Yes, you all seeing that? All right. We are finished here. Is equal to the angle in the alternate segment. Well, remember that a chord splits a circle into two parts, a big part and a small part, right? So this here in yellow, this is the small part called the minor segment. So two things. It is equal to the angle, the opposite angle in the alternate segment. So this angle here is opposite to this angle, and this angle is in the major segment. Do you all see that?
Yes.
So let me leave it there. You all read it over and see if you can follow what I did before we attempt any question. All right, you ready? If you could remember that theorem.
Go try.
All right, let me go. All right, so I want to find BOC. I want to find BOC. Which theorem would I use? I want to find BOC. Look at the diagram for you.
The angle at the center of the circle is double the angle at the circumference.
Did you all hear what he said? Did you all hear what he said?
Yeah, miss. Yeah, miss.
Do you all agree? Do you all agree with what he said?
Yeah, miss.
Yeah, 100%.
All right, thank you. So, two things. They didn't ask us for the angle alone. We had a right reason, right? Because that is how CXC brings the questions now. So, 116y. The angle at the center is twice the angle at the circumference, right? So we get our mark there. Now, we want to find AOC. Now, if this is the origin and this line touches the circumference and this line touches the circumference, how do we call those lines in purple? What's the name of them? Radius, diameter, chord. What do we call it?
Radius.
Radius.
If a triangle is bounded by two radii, what type of triangle do we form?
Isosceles.
Thank you. Thank you. It's an isosceles. So work out for me this angle and work out for me this angle. And don't say the answer. Let the others work it out. Work out the angle at B and the angle at C. I got 32 degrees. Could anybody confirm that?
Yes, miss.
Yes,
miss.
Right, 32 degrees. Now, watch this. Let me draw this in a different color. This is a chord. This is my tangent. And this is the opposite angle. So if this angle is 74, the angle in the alternate segment is also 74. So if this whole angle is 74, this whole angle is 74, and this part is 32, what is this part? Anybody?
42.
42.
Yes, 42. Do you all agree?
Yeah, miss.
Yeah, miss.
Right, we're going again. Watch this one. Last one, and we're doing one past paper question and have some for you all to try for homework. Right? Now, this is, we want to show that BAD, we want to find the angle BAD. All right, so let's see how we can go ahead and find that. We know that AD is parallel to BC. We know that it is a cyclic quadrilateral, right? But they gave us some other information. This is the chord. Yes?
Yes, miss.
Yes, miss.
Right? This is the tangent. This angle is 32. So it means that this angle here is also 32 degrees. And these Z-shape, a Z-shape or alternate angles, what do we know about them? Z-shape angles or alternate angles are equal,
They are
not
equal.
so?
Yeah,
So
miss.
this angle here will be 32. So if this angle is 32, what would this angle here be? If it is an isosceles triangle.
Yes, 32, miss.
52.
32. Could you work out the angle at C?
Yeah, miss.
Go ahead.
The 160,
160, how much again?
116.
116. Do you all agree?
Yeah, miss.
Yes, miss.
Right. So here is 116. This is a cyclic quadrilateral. So what you know about this angle and this angle, they add up to 180, not so?
Yeah, miss.
So find the value of A.
64.
64? Did you all get that?
Yes,
Yeah,
miss.
miss.
All right, we're going to some past papers now. This one is taken from, I can't remember. The diagram below, and why I picked it out, because they brought the word congruent. In 2021 paper, they brought congruent triangles, right? So I thought that this was a good question to do with you all. Now, without me saying anything, right? This side here is the radius, and this side here is the radius. So this is an isosceles triangle, not so?
Yes, miss.
All right. This passes through the origin. How do we call a line that passes through the origin?
The diameter.
Diameter. What theorem do you associate with the diameter? Okay, what does this say? The angle in the semicircle is a
90 degrees.
90 degrees. So we go in again. Watch this. So this angle is a 90 degrees. We want to find OUZ. Can you find this angle here for me and this angle here and then find the angle at Z? Can you do that?
Yeah, miss.
Remember, this is an isosceles. So find this angle here at X and then find the angle at Z. Go ahead. Find the angle at X and then find the angle at Z. Are we ready? Or are you still working? All right. Who can give me the value of X?
55.
Yeah, miss. 55.
All right, we have 55. Do you all agree?
Yeah, miss.
Yes,
Right.
miss.
So if X
Yeah,
is
miss.
55, what is the value of Z?
Z.
55.
No, this part here is 65, but I want this angle here. What's your triangle? What's your triangle?
Uh-huh.
How much is this angle here? We have a 90, we have 55. How much is this?
90 plus 55. 90 will be
145, no?
Here we have a 90 degrees. At C, I want the angle at Z, and the angle at X is 55. How much is the angle at Z?
Miss 35.
Yes, exactly, 35. Did you all get that?
Yeah,
Yeah,
miss.
miss.
And the reason is,
Yes.
CXZ is a right angle triangle. All right, let me erase this. So we know so far this angle here is 35. We want to find UVY. So UVY. But what do you know about a radius meeting a tangent? What angle is formed when the radius meets the tangent?
A right angle.
A right angle. So, right, it is a right angle. What is this angle here if they are on the same segment? Angles on the same segment are equal, not so?
Yeah, miss.
So if this angle here in yellow is 35, how much is this angle here?
It will be 35 as well.
That will be 35, right? So if we know, here's what we know. I'm drawing a triangle here. The angle at U is 90 degrees because the radius touches the tangent at 90 degrees. So here is 90. We want to find the value of V. Work it out. Do we have an answer? (180 minus 90 minus 35.
It's 55, miss.
Yes. Do you all agree it is 55 degrees?
Yes, miss.
Yes,
Because
miss.
YUV is a right angle triangle. All right, we are finished yet. We're almost there. And then we're going on to the next part of the question 9, right? We're almost there. Let me erase this. Now, we go into UVO. Right. This is 90 degrees. This is the tangent. This is the radius. It meets at 90 degrees. Find the value of W. You get a small value.
20.
20
Yes.
degrees, miss.
20 degrees. Very good. You all got 20?
Yeah, miss.
Yep.
Yeah, miss.
Right. And this part is why I chose this question, to prove that they are congruent. Congruent triangles must have the sides that are same length and the angles must be the same. So let us go. We're looking at OUZ. So which triangle looks exactly like this one? Not this one here.
Yeah, miss.
Do you all see that these triangles are congruent?
Yeah, miss.
Yes,
So this is OXY. That was the first part. Then we go into YXU. So which triangle looks the same as this one here?
The one on the
XUW.
XUW.
Yeah,
Did you all hear what she said?
yes, miss.
Just now. XU, no, XU, not XUW. Look at here. XUZ.
XUZ.
Look, it's XUZ. Do you all see that? Do you all see that?
Yeah, miss.
So for two triangles to be congruent, the triangles must have the same sides and the same angles. Now, in my worksheet, there are some practice questions. So this one was taken from, I can't remember, but I know this is the 2021 paper. This one is the 2019 paper, right? So there are some practice questions. I suggest you do them and you redo all the questions that we did today, right? And I will send you the solutions of the practice questions on Sunday, all right? Now, we finish the first half of question 9. Based on what I did with you today, which are all the theorems, you are supposed to look at any past paper and be able to look at it and do the circle theorems question, right? That is why instead of me doing full-fledged past papers, I decided to do a worksheet with the question and the theorem. So we're going back to the past papers for trigonometry. Question 9 is broken down into trigonometry and geometry. This was the geometry part. This was the circle theorems. So when we return from our break, we are going to do bearings, angle of elevation and depression, and trigonometry. So it is 4:29. I am giving you a break for 7 minutes, right? You all go and come back in 7 minutes time and we're going on to bearings. Okay, so go and get some water, get something to eat and come back here in 7 minutes. All right?
Yeah, miss.
All right, have you all written?
Yeah, miss.
All right. So this one in 2021 January and in 2020 January paper, CXC decided to bring circle theorems with bearings. So I am going to do one question with you, which is the 2020 paper, and this one is taken from the 2020 paper. You all will do that one for homework, and I will send the solution, right? So let us see what they are asking, and let's see how best we can answer this question. From a harbor H, the bearings of two buoys, S and Q, are 185 degrees. So you all see the 185 degrees here and 311 degrees respectively. Now, bearings are always measured from the north line. So what do I mean bearings are measured from the north line? This is my north line. The bearing from H, it means that I put my north line at the point H. And the bearing from H of S, so I start from my north line and I measure this angle here, meeting the line at S. And that angle is 185 degrees. Do you all see that?
Yes.
Now, the second part is the bearing from H again is 311, and that is to point Q. So let me use a different color. So from H again, we measure the bearing from H, and this entire angle this part here, which is 185, plus this part here to meet the line Q, this entire angle here is 311. Do you all see that?
Yes, miss.
Yes, miss.
Right. So I'm going to erase this. Remember two things. Bearings are always measured from the north line, and we measure in a clockwise direction. So on the diagram below, which shows the sketch of the information, insert the values of marked angles Q, H, and S. So very quickly, this is January 2021. Draw a sketch of this in your notebook very quickly because we had to label it. Right? So go ahead and draw a sketch of the diagram. So Q is 5.4 kilometers. So we label here 5.4 kilometers. S is 3.5 kilometers. And well, if the entire angle, this is what I have here. This entire angle here is 311. And this part here is 185. So the part at H will be 311 minus 185. Here would be 126. All right, so take down the diagram quickly in your book. The angle Q,
Must be 125.
QHS 311 minus 185 is 126. Check it out.
Yeah. No. Yeah, Mr. Correct.
Marcos, also, you have to. I was looking at it.
Malik, mute your mic now.
Apologies.
Let me know when you all are finished with the drawing. Yeah, right. Any whole question, please, you just drawing the diagram quickly.
Yeah, Mr. Finish.
So when you're finished, just draw this triangle for me. This is HQS. Here is 126. This is the angle here. This side is 3.5 and this side is 5.4. So draw that for me underneath the diagram. All right, are you all ready?
Yeah, miss.
Now, remember to find missing sides. If it is a right angle triangle, we can use Pythagoras' theorem or we can use trig ratios. But when the triangle is not a right angle, we have to use either the sine rule or the cosine rule. And the information in the question will determine which rule we use. Here I have two sides and the included angle. So this tells me that I am going to use the cosine rule. And in your front cover of your mathematics past papers, all the rules are there if you forget it. So look, I have the cosine rule. I placed it for you in the question. So using, follow with me and then you will write, okay? Using the cosine rule. What does the cosine rule? say? Well, let me tell you. The side opposite the angle, which is QS squared is equal to this side squared, 3.5 squared, plus 5.4 squared minus 2 by 3.5 by 5.4 multiplied by cosine 126. Now we're going to remove this brackets and I'm going to put it here. So you can multiply everything and put it in the calculator. So in the calculator, put 3.5 squared plus 5.4 squared minus open bracket 2 multiplied by 3.5 by 5.5, 5.4 cosine 126. Go ahead, work it out. And when you get the answer, QS would be the square root of the answer above. And you're writing it for me correct to 2 decimal places, unless otherwise stated.
Finishes.
Give the others a few minutes. All right, here I have the square root, no, not the square root yet. This part here is 63.628, and the square root of that to 2 decimal places, I have 7.98. Do you all have that?
Yes,
Yes,
miss.
Miss.
All right, very good. So that was part 2. Let us see what they ask in part 3. Oh, I didn't put part 3. Part 3 was, I didn't put it in the question. All right.
She was a bearing of S from Q.
Yes. Thank you, Hannah.
That
We'll
was
write it in here. Part 3 was the bearing of S from Q. That was part 3. I don't know how I forgot it. So, which means we're going to draw my note line from S because the bearing is measured from Q. Sorry, we put in the note line at Q because the bearing is measured from the point Q. And we measure in this entire angle here to point S. So it means that this angle here, if the entire thing here is worth 311, this part here would be 49. because 49 plus 311 will give me 360, right? Now, co-interior angles or U-shaped angles add up to 180. So it means that this is 49. Here would be 180 minus 49, which is 131. So it means that I need to find this angle here, this angle, right? So if I have to find that angle, I need to redraw that triangle. So let me draw it and you will tell me which of the rules would I use. So this is what I have here. So this is the angle I want at Q. I have, this is S. This value here is 7.98. It is opposite to 126, right? Let me draw it exactly so you all could see it just now. Right. So this is Q. I want to find this angle here, Q. This here is 126, right? This side we just work out to be 7.98, right? This side is 3.5. So 3.5 is opposite to Q and 7.98 is opposite to 126. Do you all see that?
Yes.
So I am going to use the sine rule. Using the sine rule, I don't have two sides and included angle, so I can't use the cosine rule. The sine rule, A over sine A is equal to B over sine B. So the length of the side, 7.98. 7.98 divided by the angle, sine 126 is equal to 3.5 over sine Q. Work out sine Q for me. Look at it. Work out sine Q. So the first thing you're going to do, you're going to flip both sides of the equation. If we want sine Q to be in the numerator. So flip both sides of the equation. So sine Q over 3.5 is equal to sine 126 over 7.98. And work out sine 126 divided by 7.98. And then you multiply that by 3.5 and you find sine inverse of that. So sine 126 divided by 7.98 is 0.101 is equal to sine Q over 3.5. So when I cross multiply, 3.5 multiplied by 0.101 is equal to sine Q. So Q is equal to sine inverse, which is second function sine of 0.35. And I will get 20.78 degrees. Work it out and see if you can confirm my answer, please.
Miss, I get 20.7.
I tell you, it's a 2 decimal places.
Oh, sure. That's it.
Check it and see if you get the same answer.
Yeah, miss, I get the same answer.
Miss, I getting 20.48.
20.48?
Yeah, I'm not sure.
Yeah, because I use the whole value in my calculator. All right, let me take the 20.48 because I did tell you to use 0.35, right? I just use the whole value in the calculator, that is why.
Okay.
I have a question. Like how you use the whole value in the calculator, if you keep on doing that for all the questions and write the whole answer in your paper.
Well, here's what to do, right? Here's what I should have told you all. Here's what I should have told you. Work out 3.5 by 0.101 and tell me what you get.
0.3548320015.
No, this part alone, Hannah, the 3.5 by 0.101.
Excuse miss, I could ask a
Yes.
question. Enter
Yes.
this is how I just work it out, miss. 3.5 multiplied by sine 126 over 7.98. And you will get 0.3550, right, miss?
Mm-hmm.
And then when you're saying it, you'll get 20.79. That's what I do. That's how I know how to do it, miss. I don't know. Oh, that's all right.
All right, Jason. All right. Let me see if we get it 20.79, right? Let's see if we get it. Because we're looking at accuracy. Because if we approximate it, it changes in the value. Because Anelia get 20.48 and you getting 20.7, which is two different answers, right? It is way off. Now, work out this piece for me here. And tell me what you all get. 3.5 by 0.101.
Point 3535.
Yes, 0.3535. So you see, I have 4 decimal places here, right? Let me see if we get it 20.78. So Q is sine inverse of 0.3535. Work out that.
20.70, miss.
20.70. So we will take that. So,
Okay.
so remember, when you're working it out, try not to approximate it to 2 decimal places as yet. So you see in my answer here, I have 3 decimal places. If you wish, you could go up to 4 decimal places. After 4, that is not required. Just to make sure your answer is accurate, right? When you're doing the sine inverse here, ensure that it is about 3 or 4 decimal places to ensure that it is correct, okay? Don't worry, we're getting some more practice in the angle of elevation and depression. That one coming up.
Yes, if you put the entire decimal rule, you'll be penalized.
No, because you put it entire decimal.
Okay.
Miss, but doing it my way, would it that is good as well, right?
Yes, that is fine, Jason.
All right, miss.
All right, are you all ready? Or is anyone still writing? Is anybody still writing?
No, miss.
No, miss.
The diagram below, not drawn to scale, shows 2 ships, R and S, at anchor on a lake of calm water. FT is the vertical tower, FSR is a straight line, RS is 150 meters. The angles of elevation, the top of the tower from R are 40 degrees and 22 degrees respectively, right? F is the foot of the tower. So we want to find the measure of RTF. How would we find the measure of RTF? Anybody? RTF. What type of triangle is this?
Right angle.
RTF. A right angle triangle. right? Can you find this angle here for me at T?
Yes, miss.
How you find it, Hannah?
90 plus 22 and minus it from 180.
Yes, so go ahead. Find the angle at T. So here is T, F, R. This is 22. Work out for me the angle at T.
Miss 68, miss.
Yes. Do you all agree with him that the answer is 68?
Yes, miss.
Yes,
Right.
miss.
No, but they didn't ask us for that angle, no, they asked us for the angle RTS. So we have to draw a next triangle.
Miss, how come you never draw the Z to make it easy?
Because that is not Z, the lines have to be parallel for us to draw the Z shape. The lines not Z there, right? So work out the angle for me at T if here is 40 degrees. So work out this angle for me here with this triangle in purple. So you tell me the big angle is 68, but I want this angle here.
Miss your T angle, miss.
Yeah, I want the T angle.
Miss that 50, miss.
50?
Yeah, miss.
All right.
Yeah,
Do you all agree?
Yeah, miss, you correct.
Yeah, miss.
Yeah, miss.
Right. Now, if the whole angle is 68 and this piece here is 50, what is this angle?
18.
18. Do you all agree?
Yeah, miss.
Yeah, miss.
So angle RTS, here's what we looking at it, angle RTS. So this is the measure of angle I want in blue here. So this is 18 degrees. Do you all agree with me?
Yeah,
Yes,
miss.
miss.
Right. We get a chance to work out to use the sine rule again. I'm going to redraw this triangle here. So you all pay attention if you get lost during that first question. We still have some time. This is T. Here is 18. This is S. This is R. This is 22 degrees. Here is 150. Right? I want to find ST. Right. So ST is opposite to 22 degrees. Do you all see that?
Yeah, miss.
So ST over sine 22 is equal to 150 over sine 18. 150 over sine 18. Do you all see that?
Yeah, miss.
Work it out now. You could draw the triangle, right? You could draw the triangle and then you can look down. You all have an answer? Or are you all still looking? Are you all finished?
Yes, miss.
So ST over sine 22, I have 150 divided by sine 18. I have 485.41.
Miss, I get up, miss, but I thought that was wrong, miss.
Oh, and another thing, when you all are doing any question in CXC, do not erase, do not scratch off, do not liquid paper anything, right? So even if you have two ideas about working out a question, you put it down and they will have to give you the mark. So don't erase or scratch off anything. I have 181.84
Yeah, I get that.
meters. Did you all get that?
Yeah, miss.
Yes,
Yeah,
miss.
Right. The height of the tower FT. So I have here as 181.84. So I could use this triangle here because I know the length of the side opposite the angle, the 90 degrees. So let me redraw this triangle here. Now, these are the trig ratios that we're going to use. So here, this is 40. This is 181.84. This is opposite to the 90 degrees. If a side is opposite to a 90 degrees, it is called the, look. Let me look at this. Let me see what this note is saying here. So I have a 90 degrees and the side opposite to the 90 degrees is called the hypotenuse. Do you all see that?
Yeah, miss.
Yeah, miss.
Right. Angle, the side opposite the angle is called the opposite and the other side is called the adjacent. Do you all see that?
Yeah, miss.
Right. So sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. And tan opposite over adjacent. Right? So let me go. We want to find the side opposite the angle. Well, that side, the name of that side is the opposite. The side opposite the angle, this is the opposite. I have the side opposite the right angle. This is called the hypotenuse. Which trig ratio? Sine, cosine, or tan deals with opposite and hypotenuse.
Unmet.
Sine.
Sine.
Sine, yeah.
So sine of 40 degrees is equal to ft over 181.84. Work out sine 40 and multiply it by 181.84. Go ahead. And that is the height of the tower. So they can bring bearings, angles of elevation and depression, and trigonometry in the question with circle theorems. So circle theorems is 6 marks, and the other 6 marks could either be on trigonometry, angle of elevation and depression, and bearings.
Miss, if you use the sine rule, you'll get the same answer.
Yes, yes, you will get the same answer. But remember, it is if you use the sine rule to find ft, but it's a right angle triangle, so you could use the trig ratios.
Yeah, miss, but if you forget one, you just use the sine rule, you'll get the same answer, right?
You could try it and see. But Hannah, make sure if it's a right angle triangle, you don't use the sine rule and the cosine rule. Eh? The sine rule and the cosine rule is used for triangles that are not right angle. So I'm not sure if you will get the correct answer there.
Yeah, miss 16.88 for both.
Just a minute. I'll have to check that. Send it for me if you use the sine rule. Let me see. Right?
Okay, miss.
So here I have 116.88 meters. Did you all
Yeah.
get that?
Yeah, miss.
Is there anybody who didn't get that? Is there anybody who's confused?
No, miss, I get it, miss.
Is there anybody who would like me to go it over? Nobody else said anything. So I assume that you all understand it.
Miss, if you want to go to bar one more time, miss.
All right. So let me go. All right. So they asked me to find FT. So based on my diagram, each part, we use the part before to work out the part after, right? So this here is 181.84. So here, this is my triangle that I am going to redraw here for you. This is F, this is T, this is S. Here is 40 degrees. This is 181.84. The information in my question tells me which trig ratio to use. So I'll write down what information I have. I have a 40-degree angle. I have the opposite side. I want to find the opposite side. How do I know that is the opposite side? Well, it is the opposite to the angle. So FT is the opposite. And this is my 90 degree. And this side is opposite to the 90 degree. So this is called the hypotenuse. So the trig ratio that deals with opposite and hypotenuse is sine. You all remember SOHCAHTOA?
Yeah,
Yeah,
miss.
miss.
So sine of 40 degrees is equal to FT over 181.84. This is over 1. So I can cross multiply. FT is equal to sine 40 multiplied by 181.84. And I will get 116.88 meters. All right. So if you need to take down anything on the screen, you can do so now, please. All right, let's go. So this is a question that you all will try, angle of elevation and depression. And I want to do this one. This one I feel was taken from a 2021 paper. The diagram below shows a quadrilateral. A quadrilateral is a figure with 4 sides. PQ and SR are parallel. So Jason, you see, they say PQ and SR are parallel.
Yeah, miss.
So here is when we can use the alternate angles, when the lines are parallel. So you see in the Z shape here now?
Yes, miss.
Right. So SQ is 8 centimeters the angle at P is 90 degrees, the angle at Q is 82, and the angle at R is 30. So Z-shaped angles, alternate angles, this angle is equal to this angle here, 30 degrees, right? I want to find PS. PS is opposite to 30 degrees. So this is called the opposite side. Do you all see that?
Yeah, miss.
And I have the side opposite to the right angle. So that is called the hypotenuse. So which trig ratio deals with opposite and hypotenuse? Sine.
Sine.
Sine, yeah, miss.
So sine of 30 degrees is equal to PS over 8. So cross multiply. PS is equal to 8 sine 30. Work it out and tell me what you get. And you can draw the diagram. So you can draw the diagram. We have some time. The side opposite to the angle is called the opposite. And the side
4 centimeters, miss.
opposite, what did you say?
4 centimeters.
Yes. But give the others a few minutes, right? The side opposite to the right angle is called the hypotenuse. And the side opposite to the angle is called the opposite side. All right, so PS is equal to 4 cm. Did you all get that?
Yeah, miss.
Yes, miss.
Yeah.
Yeah, miss.
In the same triangle now, so we gain a good practice on trig ratios here. So P, Q, and S. This is a 90 degree. This is 8 cm. So which means I have the hypotenuse. This is my 30 degree angle. And I do not want PS this time, I want PQ. So which trig ratio deals with adjacent and hypotenuse?
Cosine. Cosine, miss.
Cosine of 30 is equal to adjacent over hypotenuse. So cosine of 30 degrees is equal to PQ over 8. PQ is 8 multiplied by cosine 30.
Wait, it rounds it out to 2 decimal places, miss.
Yeah, 2 decimal places. Who has an answer for me?
6.93 centimeters.
6.93. Could anybody confirm that answer?
Yeah, miss.
Yes, miss.
Miss.
Yeah.
All right, the last part of our question city, we want the area of PQRS. Now, PQRS, if I were to erase this, right? This is a four-sided figure. There are two parallel sides, and the name of this shape is called a trapezium. So the area of a trapezium is half the sum of the parallel sides multiplied by the height. We made that in the multiple choice. Now, I don't have this side, so I can't use the cosine rule. So it means that I need to use the sine rule in order to work out SR. So I need to know the side and I need to know the angle. So 82 is opposite to SR. Do you all see that?
Yeah, miss.
Now I need to know the angle opposite 8. What is this angle at R? Can you all find it? Can you all find that angle at R?
Yes.
How much is it? If the angles in a triangle add up to 180, what is the value of the angle R?
68.
Miss 68, miss.
68. So using the sine rule, the length of the side first, which is 8, over sine of the opposite angle, which is 68, is equal to SR over sine of the opposite angle, which is 82. Right? So work out SR for me. Divide 8 by sine 68 and then multiply that by sine 82. Work out the answer. So you can work out this piece here, right? You could work out that part to about 3 decimal
It's like
places.
8.5.
To 2 decimal places.
It's an 8.54, miss.
Yes. So the answer is 8.54. Did anybody else get that?
Yes, miss.
Yeah, miss. Me.
Yes, miss.
So the last part is to find the area now. So the area is a half the sum of the parallel sides multiplied by the height. So this side here, we work out to be 6.93, and this is parallel to this side. This is 8.54, and this is 4. So work out for me the area. A half of 6.93 plus 8.54 multiplied by 4.
$50.94. Miss.
Yes. 30.54, and what is units?
Centimeters squared.
Yes, it's area, right? So area is in centimeters squared. So check it. You all check his answer and see if it is correct.
Yes.
Let me check it out.
All right. So we have done circle theorems, and I believe that you all have a little more knowledge on the circle theorems. Am I correct?
Yeah, miss.
Yes.
All right. So we did the circle theorems, we did bearings, we did trigonometry, we did angle of elevation and depression. All I ask is that the questions on the worksheet, I will send you a blank worksheet and I will send you a worksheet with the answers. So when you all get some time before next week, Friday, practice the questions because I feel we have about 25 days again before the exam. So next week, we're looking at sequencing, which is question 8 of the CSEC past paper. And we are looking at relation functions and graphs, right? So we are on our way. For persons who join in late, I know that some of you all have exams on the 30th of June, right? We will continue our classes until the 2nd of July. That is the last day of school. That is officially the last day of school. I will tell you when we will finish the paper 1, right? So you see that weekend of the 2nd, 3rd, and 4th, that is crucial because you all will have English on the 6th and you have mathematics on the 7th. So I plan to take you all down to the very last day, all right? So thank you so much for joining me, all right? I know that we had a long class, but I will see you all on Sunday.
Enjoy the mess. Enjoy
All
the
right, bye. Bye.
Bye, miss. Enjoy the miss.
You too.